Dear students, today we are going to solve exercise 5.3. Question is, find the square roots of the following quadratic questions. Sina question ani select tore, question 5 and question number 10 select tore. Question number 5. The given quadratic question is x square plus 3x plus 5 is equal to 0. Here first write the values of a, b, c. A is the coefficient of x 1, b is the coefficient of x square 1, b is the coefficient of x 3, and c is the constant. Then find the value of discriminant. B square minus 4ac, b3 square minus 4, 1, 5, 9 minus 20 is equal to minus 11 less than 0. Since the value of discriminant is negative number, then the roots are not real number. Real number oiraroi ko. The roots of the quadratic question are given by the formula. X is equal to minus b plus minus root over b square minus 4ac divided by 2 times of a. By substituting the values of a, b, c and the value of discriminant, we have this x is equal to minus 3 plus minus root over minus 11 divided by 2, which is equal to minus 3 plus minus root over 11. This root over minus 11 can be expressed as root over 11 into root over minus 1 divided by 2. Minus 3 plus minus root over 11. 11 is not a perfect square, so root over 11 is written as root over 11. Then root over minus 1. Root over minus 1 di kay kamanay I tayo ko, where I is the imaginary number divided by 2. Then write this expression in a plus ib form, complex number form the is equal plus samaga minus samga. First, let us take the plus part of this expression. Minus 3 by 2 plus 11i by 2, and second expression is minus 3 minus 11i divided by 2. And these two complex number are the roots of the quadratic equation. X square plus 3x plus 5 is equal to 0. It's the period quadratic equation ki root sa ng complex number ani siyo na pangye ko. Next question, question number 10. The given quadratic equation is x square plus x divided by root 2 plus 1 is equal to 0. Then this x by root 2. LCM lower ko. Then find the LCM of these three terms. Here LCM is root 2. Then this root 2 multiplied by 0 is 0. 1 divided by root 2 is root 2 x square. x1 tare 1 divided by 1 into root 2 is equal to root 2. Nang LCM lower na khandragasu ko. Multiplying both sides by root 2 haragasu yai. Root 2 x square plus x plus root 2 equals to 0 into root 2. 0 tare ko. Here the value of a is equal to root 2, value of b is equal to 1, value of c is equal to root 2. Discriminant b square minus 4ac ki value yang si ko. Discriminant ki value yang aga koina nature of the roots haiba ngamdoini. We can determine the nature of the roots of the quadratic equation by taking the value of the discriminant. So we need to find this value. 1 square minus 4 into root 2 is equal to 1 minus 4. Root 2 whole square is 2, and their subtraction is minus 7. Minus 7 is less than 0. Less than 0 saladi nangi root singse real number tararoi habis dikhange ko. And the roots of the quadratic equation is given by x is equal to minus b plus minus root over b square minus 4ac divided by 2 times of a. The piriba nangi quadratic equation amagi root puthokpagi formula se use tawsi ko sijinare. Here x is equal to minus 1 plus minus value of discriminant is minus 7 divided by 2 into root 2. Minus 1 plus minus root 7 into root over minus 1. Then root over minus 1 is replaced by I na replace the record. And x is equal to minus 1 plus minus root over 7. Then sidat kay yawe. Denominator the root 2 haibam yawe. Root 2 se irrational number ni ko. Irrational number na denominator oide. Oina deva aduna irrational number se rationalize tawthok se. Rationalize the heitardi, we should multiply denominator and numerator by root 2. Minus 1 plus minus root over 7i root 2 divided by 2 into root 2 whole square. Minus 1 plus minus root 2i. Multiply by this root 2, we have minus 2 plus minus root over this root 7 into root 2 is equal to root 14. 14 dagrani ko I. and root 2 whole square is equal to plus 2. 2 into 2 is equal to 4. Then first term and second term divided by 4. Then write plus part and minus part of this expression. Plus ki saruk minus ki saruk ithok minus root 2 divided by 4 plus root over 14 divided by 4i. See the top complex number and second part is minus root 2 by 4 and a minus root over 14i divided by 4. And these two complex numbers are the roots of the quadratic equation. Quadratic equation dugi roots tare ko. Next, extra question. See important question ni ko 6 mark natraga 4 marks ta dum hangi si question che. Question number 1, extra question che x square minus x plus 1 plus I is equal to 0. See the quadratic equation ampere ko x square minus x plus 1 plus I is equal to 0. Then we are going to find the roots of this quadratic equation. First, write the values of a. A means coefficient of x square 1. Then write b. B is the coefficient of x minus 1. And c. C is equal to constant 1 plus I. Here the constant is a complex number. Then write or find the value of b square minus 4ac. B square minus 4ac ki value se ho chiko. Minus 1 whole square minus 4 1 1 plus I 1 minus 4 1 plus I the c4 na multiply to already minus 4 I tai ko 1 minus 4 is equal to minus 3. Then write this minus 4i. See ito Therefore, the roots of the equation are given by nangi roots ki formula se use to ko. Roots of the quadratic equation haibasa kaina p haradi x is equal to minus b plus minus root over b square minus 4ac divided by 2 times of a. Sina p doing 1 plus minus root over. Value of discriminant is minus 3 minus 4 divided by 2 times of a. Then write equation number 1. See the square root we need to find the square root of the complex number minus 3 minus 4i. Aina mamangi class the square root of complex number lawagi takre ko. Let the square root of the complex number minus 3 minus 4i be equal to a plus ib. A plus ib gamanahalle ko. Then squaring on both sides we have a plus bib whole square is equal to minus 3 minus 4i. By expanding this equation we have a square minus b square plus 2 times of ab is equal to minus 3 minus 4i. Simanare ko. Equating real and the imaginary parts. Real ga imaginary ga equate ko. Equating real parts and imaginary parts we have kay pangni. Nangi real parts siga imaginary parts siga equate tawre. A square minus b square is equal to minus 3 and 2 times of ab. So imaginary part siga minus 4 fange ko. So minus equation number 2 and equation number kya fange 3 fange. Then we consider the identity a square plus b square whole square, and this identity can be expressed as a square minus b square whole square plus 2 times of ab whole square. From equation number 2 and equation number 3. First term is equal to minus 3 whole square and second term is equal to minus 4 whole square. 9 plus 16, their sum is 25. A square plus b square whole square is equal to 25. Again taking square root on both sides of the equation. Since a square positive, b square positive, and their sum will be positive, and so square root of this equation will be plus when a square plus b square will be equal to plus 5. Si fange. Equation number kya tha equation number 4 harasiko. By using this equation number 2 and equation number 4, we need to find the particular values of a and b. Particular values of a, b puthok doine. First, adding equation number 2 and equation number 4. 2 ga 4 ga se add tawro. We get a square plus a square 2 times of a square. Cancelling minus b square and b square. Cancel tawre ko 0 chatkre. Minus 3 plus 5 is equal to plus 2. 2 times of a square is equal to 2, which implies that a square is equal to 1. Then taking square root on both sides, possible values of a are plus minus 1. Plus minus 1 tare ko nangi a gi oibiyaba values. From equation number 4, 1 plus b square is equal to 5, which implies that b square is 5 minus 1, 4. Taking square root on both sides, possible values of b are plus minus 2. Here we have the possible values of a and possible values of b. The correct combination choose tauta. Since the product of a, b is negative. From equation number 3, a, b की product से plus होइना फंगब्रा minus होइना फंगब्रा. a, b की product से minus होइना फंगे को. Number ani की product ना negative होई तारदी either one of them will be negative. Ani दुगी मनुंगदा अमा दी negative ओरनी. We have a is equal to 1. a na 1 लौरदी b से minus होएगा. If a is equal to minus 1, b will be equal to plus 2. Therefore, the square root of the complex number minus 3 minus 4i is equal to a plus ib निको. If a is equal to 1, b will be minus 2 multiplied by a, or if a is equal to minus 1, b will be plus 2i. These are the roots of the complex number minus 3 minus 4i. By substituting these roots in the equation number 1. Equation number 1 dane magi root की value से सिगी 1 plus minus root over minus 3 4i by 2 नेबा. सिगी महुत्ता आइना हुजे कइना सिंतारे 1 minus 2i have maga minus 1 plus 2i have a substitute को. From equation number 1, the roots of the equation are given by x is 1 plus minus 1 minus 2i. Atopa mana from equation number 1, x is equal to 1 plus minus 1 minus 2i siana seleko. 1 minus 2i divided by 2, or 1 plus minus haraga second part ki kaisene. Second part ki ina lagtu se minus 1 plus 2i se oiduin. Minus 1 plus kay lakadaba 2i. Minus 1 plus 2i se pireko. Minus 1 plus 2i. Sidagi expression ani fangani. Sidagi expression ani fangniko. Sigi expression ani maksa chap mananeba. Chap managadabani si first part sidagi root ani se lower siko. 1 plus 1 minus 2i lereko. Divided by 2, and minus part tadi 1. Plus minus minus plus 2i divided by 2. Sidagi expression ani fangani. Sidagi expression ani fangani. Expression ani do chap manaba value puthokani. Aduna koina first part che sidagi oina plus su lore, amana kay lore minus lore ko. 1 plus 1 is 2 minus 2i. 1 plus minus 1 is equal to 0 chale ko. 2i fangore. Then dividing 2 minus 2i by 2, we have 1 minus i. 2i divided by 2 is equal to i. 1 minus I and the plus I are the roots of the quadratic equation. Nangi quadratic equation, nangi given quadratic equation do atugi roots oideba. Quadratic equation se kaino x square minus x plus 1 plus I is equal to 0 haibasa sigi quadratic equation ni ko. Next question, question number 2. 2019 da hangba question ni ko. X square minus root 2 plus ix plus root 2i is equal to 0. Quadratic equation sigi roots puto o haiba ko. Find the roots of this quadratic equation. First, we have to write all the values of a, b, c. A, b, c ki value igadawa. Value of a is equal to 1. Value of b is equal to minus root 2i. Value of c is root 2i. A, b, c ito ko. Then find the value of discriminant. B square minus 4ac is equal to minus 1 whole square is equal to plus 1. And so b square root 2 plus I whole square lere ko minus 4 into 1 into c. C की value से क्या नो root 2i lere. Root 2 plus I whole square hai tar di si kai sijinani expand tawba kanda a plus b whole square sijinarani ko. Root 2 whole square plus 2 into root 2i plus then I square minus 4 root 2i. Sumaina ito root 2 whole square is equal to plus 2. 2 root 2i. Then value of I square is equal to minus 1 tare ko. Minus 4 root 2i. Sumaina later. Stagi nang na real part and imaginary part kansi ko. 2 dagi minus 1 khaidokra di 1 tare. 2 root 2i dagi minus 4 root 2i di minus 2 ina leme ko. minus 2 root 2i sumaina. Value of discriminant se b square minus 4ac se kaiga manare 1 minus 2 root 2i se tare ko se complex number oin phangi. Complex number oirabanina nangi roots of the quadratic equation se complex number nga ta oirani. Then we can find the roots of the quadratic equation by using the formula x is equal to minus b plus minus root over b square minus 4ac divided by 2 times of a. Here value of b is equal to minus root 2 plus I. Minus minus plus. It will be equal to root 2 plus I. Plus minus lere ko root over discriminant की value से 1 minus 2 root 2 I से divided by 2 times of a, which is equal to root 2 plus I plus minus root over 1 minus 2 root 2i. 2 into 1d 2 tare ko, and then write this equation number 1. See about the equation number 1 thamani kaigino haradi we need to find the square root of the complex number 1 minus 2 root 2i habasegi square root puthokpam change ko. Now let us suppose that the square root of 1 minus 2 root 2i is equal to a plus ib. Any complex number a plus ib ni ko. Then find the particular values of a and the b. A, b ki particular values hoto ini. Squaring on both sides. A plus ib whole square is equal to 1 minus 2 root 2i. Sigma na hale ko. Expand to by expanding this expression we have a square minus b square plus 2 times of abi is equal to 1 minus 2i. Left hand side and right hand side complex number ani phange. Then by equating real and the imaginary parts of the above equation. Mathak ta piriba nangi complex number ani sigi real part ka imaginary part ka kaidore koina equate tawre ko. Si equate tawba matamda we have two equations. First one is a square minus b square is equal to plus 1. Write equation number 2, and second one is imaginary part. These 2 times of ab will be equal to imaginary part minus 2 root 2. So main tawraga koina equation ani phange ko. Question number 2 and question number kyano 3. Then we consider the identity. A square plus b square whole square is equal to kaiga manarani a square minus b square whole square plus 2 times of ab whole square. Sigi expansion siga chap manabani ko. From equation number 2 and 3, first term is equal to 1 square and this second term is equal to minus 2 root 2 whole square. Tare ko 1 minus 2 whole square di 4 into 2 angka hole 9 tare. Sigi value sigi expression puthokpa se 9 phange ko. Taking square root on both sides. A square plus b square is equal to 3. Write equation number 4. By using this equation number 2 and equation number 4, we need to find the values of a and b. First, adding equation number 2 and 3, we get 2 times of a square, and 1 plus 3 is equal to 4 implies dividing both sides by 2, a square is equal to plus 2, which implies that a is equal to plus minus root over 2. From equation number 4 dagi 2 plus b square is equal to 3 implies b square is equal to 3 minus 2. 3 dagi 2 khaidokre 1 tare ko. Dudi nangi possible values of b ja kya hoibe yare. Possible values of b are plus minus 1. So minus a gisu value ani phangre ko plus minus root 2. B gisu kya lere plus minus 2 lere. Sidagi karamba correct combination hai tare a ga b ga a gi value ga b gi value ga karamba chumba khangadage na hang taragadi kaina pirakani se equation number 3 gi product of a b gi condition na p doini ko. From equation number 3, since the product a b is positive or negative, si check tau tho negative in phange. If the product of two numbers is negative, which implies that either one of them will be negative. So if a is positive, b will be negative. If a is negative, then b will be equal to positive. So a na positive already, b negative. A na negative already, b do mo kay learn positive lore ko. And therefore the square root of the complex number 1 minus 2 root 2i, which is equal to a minus 1i or a minus root 2 plus 1. See values hapchile ko. Then by substituting the the square root of complex number 1 minus 2 root 2I in equation number 1 the happen ko. The x is equal to root 2 plus I plus minus. First write this complex number root 2 minus I, or root 2 plus I plus minus, then write this complex number minus root 2 plus I. Chumai ito eba. We will get two complex number from this expression and two complex number from this expression, but the two expression are same. Sigi expression ani do chap manani ko duna sidagi na law si ko plus and minus sidagi na ko na two complex number ani do khallase. Ahanbada plus part chana law root 2 plus I root 2 plus into minus 1 d minus tare ko minus I divided by 2, and then write the negative part of this expression. Negative part se kaitani root 2 plus I plus minus minus root 2 minus 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 plus I divided by 2. Sumai ito the complex number ama phange, complex number ani phange ko first and second. Tuti hojiki complex numbers damtang yengsi ko. Ahanbagi complex number sida cancelling plus I and minus I. We have root 2 plus root 2, 2 root 2 by 2 phange ko. Then for the second complex number, cancelling plus root 2 and minus root 2, I plus I is equal to 2I divided by 5. X se 2 root 2 by 2 ni ko, amana 2I by kay tare 2 tare. 2 na divide out the root 2 amaga I ga phange ko. And these are the roots of the given quadratic equation. The given quadratic equation is x square minus root 2ix plus root 2I have a quadratic equation je. Sigi roots ni. Sigi quadratic equation ki type amadi adum hangani ko 6 marks or 4 marks. Here last question is question number 3. Extra question ni. The given quadratic equation is 2x square plus 3ix plus 2 is equal to 0. Write the values of a, b, and c. A is 2, b is equal to 3i, and c is equal to 2. Find the value of the discriminant b square minus 4ac. 3i whole square minus 4 into 2, 2. 3 square 9. I square is equal to minus 1. 4 into 4, 16. Minus 9 minus 16 is equal to minus 25. Since minus 25 is less than 0, 0 de hantare ko. And so the roots of the quadratic equation are not a real number. It must be complex number. And we can find the roots of the quadratic equation by using this formula. X is equal to minus b plus minus root over b square minus 4c divided by 2 times of a, which is equal to 3. Value of b is 3i. Then we write minus 3i plus minus root over minus 25 by 2 into 2. 2 into 2 is equal to 4 ko. Minus 3i plus minus 5. Root over 25 is 5 and root over minus 1. 2 gi 4 later ko. Minus 3i plus minus 5 since root over minus 1. Root over minus 1 have se kai gamane I gamane ko divided by 4. Minus 3i plus part and minus part is equal plus minus 5i by 4, and minus part is minus 3 and minus 5i divided by 4. Minus 3i ga 5i ga subtract taunaradi 2i am leme ko. Minus 3 plus minus 5 haradi minus 8 ni. Minus 8i divided by 4. First expression is I by 2. The reduced over second expression is equal to minus 2i. These are the roots of the quadratic equation. 2 times of x square plus 3ix plus 2 have a quadratic equation sigi roots natani ko. For today, let's end here.